Hello students, today we are going to take up the third method of integration, which is called as integration by parts. It is used for finding the integrals of product of two functions. Now suppose, it is used to find integrals of products of two functions. Okay, now suppose we are given ux and vx are two functions of x such that we are required to find the integral. We have to find the integral of u into v into dx. That is, suppose we are required to find the integral of the product of two functions u and v, where both u and v are functions of x. Then what we do is, now the formula, the integration by parts says that uv dx is equal to first function into integral of the second function minus integral of derivative of the first function into integral of the second function whole integral. So this is the formula. And how do we remember this? So the integral of product of two functions u into v dx is equal to first function, which is u here. So we call it first and we call it second. Okay, so if we call this as first and this as second, then the formula says it is equal to first function into integral of the second function minus integral of the product of derivative of first function and the integral of second function. Okay, so this is the formula. Now let us see how we use it. Like for example, if the function is, suppose we have x into, let's say, cos x dx. So we take this as the first function and this as the second function. So what will we write? First function as it is into integral of the second function dx minus integral of derivative of the first function into integral of the second function dx. So this is the formula. Okay, so when we start solving it, we get x into, now integral of cos x is sin x minus integral of, now derivative of x is 1 into integral of cos x is sin x into dx. Now here what do we observe? That we still have an integral left, but the product, like the function which was in product with the trigonometric function, has vanished. And this is what is the use of this integral by parts. Okay, so here we still have to find the integral, but only of a single trigonometric function whose integral we know. So x sin x minus integral of sin x is minus cos x plus c, and so the result comes out to be x sin x plus cos x plus c. So a function which otherwise felt we just didn't know how to solve, but using this method of integration by parts we could solve it very easily. Now the question arises that is there a method of choosing the first function and the second function, or we just choose it like that? Or what is the use of the first function and what is the use of second function in this procedure? Now if you observe carefully, the first function in this entire procedure doesn't get integrated at all. It is either used as it is in the first term, or it is first differentiated and then used. Okay, whereas the second function is integrated in the first term as well as in the second term. So it means we have to choose the second function as that function whose integral we know, whereas first function is restricted to those whose integrals are either difficult to find or we are not aware of these integrals. And for that we have a very easy method called as isolate. Helps us choose the first function. So whichever comes first as we move from left to right. So whichever function comes, so we choose from left to right. Now isolate stands for, I'll just write it again, isolate. The full form, isolate, I means inverse trigonometric functions, L means logarithmic functions, A means algebraic functions, T means trigonometric function, and E means exponential function. Now what is the use of isolate? Okay, now whatever two functions we are given as a product for finding the integral. Okay, so as we move so we have the two functions, so whichever function comes first as we move from left to right on this isolate is taken as the first function and the other one as the second. So like in this example we have x is an algebraic function and t is a trigonometric function. As we move left to right along this isolate, algebraic function comes before the trigonometric function, and so we choose x to be the first function. Okay, and this helps us a great lot. Like suppose we don't follow it, then what happens? See, whatever comes to your mind, you have to actually try it out and prove it and check it. Now suppose we don't follow isolate. Okay, so then what do we have? We have x cos x dx. So suppose we take this as the first and this is the second. So according to the integration by parts, what will we have? First function into integral of the second function minus integral of derivative of the first function into integral of second function whole integral. So when you solve it, what happens is cos x becomes cos x is as it is, integral of x becomes x squared over 2 minus integral of derivative of cos x is minus sin x, and integral of x is x squared over 2 into dx. So instead of getting simplified, it has become even more complex function, because see, if we had taken, like in the previous case when we had taken x as the first function, after finding the derivative that x got removed, and in the second integral we got only the trigonometric function, which was easy to solve. Whereas here on taking x as the second function, the power of x has become even more than what was given to us, and now this has become more complicated. So more complicated, and hence not the correct way of doing it. Okay, and hence we follow isolate. Okay, so isolate helps us to simplify this function to a great extent. Okay, like for example, now let's start with exercise 7.6. Let's take this question number 3. Now here we have I is equal to x squared e raised to power x dx. Now this is, now again we check for I late. Now x square is an algebraic function and the second one is an exponential function. So what comes first as we move from left to right? The algebraic function. So we take it as the first function, we take this as the second function. And so what do we observe? We get it as first function into integral of the second function minus derivative of the first function into integral of the second function whole integral, and this gives us, this is x squared. So x squared integral of e raised to power x is e raised to power x only minus this gives us 2x e raised to power x dx. Now we are still left, though the power of x has got reduced, but we are still left with another product of two functions. So again this we take as first function and this as the second function. So we have to apply integration by parts again. So what do we get? I is equal to, this is as it is, x squared e raised to power x, and we will be putting c, that is the constant, only towards the end. Okay, so minus 2 is outside. Now x e raised to power of x, first function into integral of the second, which is e raised to power x minus integral of derivative of the first function is 1 into integral of the second function is e raised to power x into dx, and now this comes out to be I is equal to x squared e raised to power x 2 times x e raised to power x minus, now again this integral is e raised to power x plus a constant, and so we get I as x squared e raised to power x minus 2x e raised to power x minus of our minus becomes plus 2 e raised to power x plus a constant, which is the answer. Now a very important use of the method of integration by parts. It helps us to find the integrals of log x and the inverse trigonometric functions, which we don't know. We don't have these results for the integral of log x and the inverse trigonometric functions. Okay, now so to start, first case we are taking up to find the integral of log x. So what we do is, so we have to find integral of log x dx. We treat log x as the first function because we don't know the integral. Now you will say that there is only one function, so we write it as 1 into log x, which we are allowed to do. So anything which we are given, we can write it as 1 into that. Now if you just follow isolate, okay, log comes before the algebraic function. 1 is a part of the algebraic function and log is first as we move from left to right. So treating this as the first function and 1 as the second function. So what do we get? I comes out to be first function into integral of 1 dx minus derivative of the first function into integral of 1 dx whole dx, and so I comes out to be x log x minus, this is 1 upon x into x dx. This gets cancelled. I gives you I is equal to x log x minus, now integral of 1 is again x plus a constant. So this is the, so thus we have a very important result, that integral of log x is equal to x log x minus x plus a constant. If you want, you can remember this result and use it, or you can simply use it by solving then and there. The same way we can try out the integrals of the various inverse trigonometric functions. Like for example, let's find the integral of sine inverse x dx. Again we will write it as 1 into sine inverse x into dx. Again following isolate the inverse trigonometric function is first and 1 is the algebraic function, and so we treat inverse trigonometric function as the first function and the algebraic function as the second one, and so we get I is equal to first function, that is sine inverse x, into integral of the second function minus integral of derivative of the first function, that is 1 upon under root of 1 minus x squared, into integral of the second one into dx, and so we get this I comes out to be, this is x sine inverse x minus, here we get x upon under root of 1 minus x squared into dx. Now here we can make use of substitution. Put 1 minus x squared as t, we get minus 2x dx is dt, and so we get I is equal to x sine inverse x. Now minus x dx can be written as dt upon minus half into t raised by half, which can be easily solved. So let's quickly complete it. So what do we get? We get I as x sine inverse x, minus of minus is plus half, and then we have t raised by minus half into dt, and this gives us I is equal to x sine inverse x plus half into, now the integral of this will be t raised by half upon half, this gets cancelled, plus a c, replace back the value of t, we get sine inverse x plus, we had put t as 1 minus x squared, so 1 minus x squared raised to the power half plus c, and so the result we get is sine inverse x dx is equal to x sine inverse x plus square root of 1 minus x squared plus c. So this is another result. So similarly we can find the results for the integrals of all the inverse trigonometric functions using the method of integration by parts and treating the inverse trigonometric function as the first function and 1 as the second function. Okay, so same way we can find the rest of the results, so that you can try it out. And so now if we continue with the exercise 7.6, we can do the other problems also. So suppose I take up question number 4. Okay, now question number 4 says I is equal to x log x dx. Okay, so using isolate we will take, now here we have one log function and one algebraic function as we move from left to right. So treating this as the first function, this as the second function. So what do we get? I is equal to first function into integral of the second. Now integral of x is x squared by 2 minus integral of derivative of the first function into integral of the second function into dx. Solving we get x squared by 2 log x minus 1x gets cancelled, half is outside, integral of x dx, which gives us I is equal to x squared by 2 log x minus half of x squared by 2 plus a constant, which on putting together gives us x squared by 2 log x minus x squared by 4 plus a constant, which is the answer. Same way you can try out the other questions of this exercise. Thank you.